Hello everyone, my name is Lucas Melodic. This is my CS6963 Spring 2015 final project. For my final project, I chose to work on a file signature scanner in Python. What my program does is, for any given file, it will check its file signature versus the file extension and match it against a known database of file signatures and their extensions. It will also attempt to read through the header or the beginning of the file for other potential file signatures and will output any others found at a particular offset, as well as account for these other file signatures. This video will serve as a brief demo. Let's get started. Here we have the fss.py. This is the actual program or script that will be running, as well the database of known file signatures that it comes with. Here are some test cases for the program. One file with no signature, one file with no extension, a few good examples, as well as a few bad examples. First, you run the program from the command line as normal using Python, fss.py, and you can use -h for help in case you want to check any of the flags or options. For use on an individual file, you use the -f option, and then specify what file you want to check. The program will output the results to an Excel file in the same directory with fssresults.xls as the name. Here you can see the file name specified, the test1, which is the test of whether or not the extension and the signature match, as well as other file signatures found within the first 50 bytes of the file. I chose 50 bytes just as a certain delimiter. You can change the delimiter yourself, or if the file is shorter than 50, it will scan the entirety of the file. Now let's look at the results when we run it on a program with no extension. Here you can see that there's no file extension specified, and so it'll just halt. The file that the program's operating on has to have a valid extension as well as a valid file signature. The two fail cases for the program would be if the signature is not in the database, as should be the example for bad.doc. What happens is, since the database should be a trusted source of known file signatures and their extensions, if the signature is not in the database, then it should be something to be looked at, since all file signatures should be known for known file types. Lastly, the other fail case is if the extension does not match the signature proposed by the file. Here we have an example called bad.jpg. It's actually a PDF file that I changed the header of and stripped and changed the extension to mask it as a JPEG file. As you can see, if we run the program on bad.jpg, what will happen is the first test results will fail because the extension and the signature don't match. The second test will show you different file signatures found, like PDF, for example, at a certain offset. This is also a count of the number of signatures found. Now we can use ghex, a hex editor, to confirm our findings with the program. As you can see here, D0CF11 is not the normal PDF header, but rather further on in the file you can see a PDF header. I believe D0CF is actually for a doc file, so maybe this was previously a doc. More useful approach is to be able to run on files en masse. You can do this by specifying the -D option for a directory or -DI for a disk image. Here we have a tests file, tests directory that contains all of these files, but we'll be able to run it on all of them at once. Again, the results will be outputted to this Excel file. If you'd like to save your results, you have to rename the file because it gets overwritten each time you run the program. Here we can see the results for all of the files, whether or not the signature and the extension match, whether there was a file extension provided, whether the signature is empty or not, and then whether or not it's a pass or fail condition is based upon red or black. Lastly, using the sleuth kit, you can specify the -di option and carve files from a disk image. My program will then run on those files carved from the sleuth kit. I chose one of the files we used as a previous homework assignment as an example. Here you can see output from the sleuth kit. The number of files recovered is 22. It's finished running and it saved the output to the TSK output file. Now my program will run on the recovered files. It does not run recursively on subdirectories due to problems with $signs, symbols, spaces, odd load. It ended up, the recursive calls ended up being a problem. So you can actually specify manually -d and run it on subdirectories. But for now, let's just check the output. Here we can see all the files that were recovered from the disk image, as well as whether or not they passed the first test. For a majority of the files, my program will attempt to explain why the program failed. For example, this program has a file signature of FFD8FFE0, which is JPEG image. It uses the database lookup to do that. However, the extension is specified as XLXS. It's obviously an Excel file for 2007 and later, but for some reason the file signature has been overwritten. Let's confirm my program's findings using the file command. And the file command has determined the same thing, that based on the file signature, this is actually JPEG image data and not an Excel file. Lastly, we can use a hex editor for further verification. And sure enough, .jfif or .jpg is